Imagine standing on the surface of Mars, feeling the soft crunch of rust-colored dust beneath your feet. You look up, expecting to see the comforting blue sky of Earth. But instead, a faded, dusty pink looms overhead. The air is unbreathable, thin, almost non-existent, carrying only the faint whisper of ancient storms long gone. The land stretches endlessly, a barren wasteland of craters, rocky cliffs, and towering volcanoes frozen in time. But what if I told you it wasn't always like this? Mars was once a world of rivers, lakes, and possibly even oceans. Billions of years ago, it had a thick atmosphere, clouds, rain, and a climate that may have been warm and stable enough to support life. In some ways, it was Earth's twin, a planet filled with potential. But then something went terribly wrong. The rivers dried up, the air vanished, the planet transformed into the frozen desert we see today. What happened? What force could turn a world so similar to ours into an empty, lifeless husk? And here's the real question. If Mars could change so dramatically, could Earth suffer the same fate? Before we dive into these mysteries, let's take a quick pause. If you love exploring the secrets of space, you're in the right place. Every great journey starts with a few brave explorers, and right now Cosmic Whispers is just beginning. You can be part of it. So if you enjoy unraveling the mysteries of the universe, hit subscribe. It's free, and it helps us grow this community together. Now let's rewind time, billions of years into the past. To understand what happened to Mars, we need to examine the traces left behind. Scientists have found evidence of ancient riverbeds, dried-up lake basins, and even what could have been a vast northern ocean. These aren't just theories. These are physical scars on the planet's surface, remnants of a time when water flowed freely. The Curiosity and Perseverance rovers have found minerals that only form in liquid water, proving beyond a doubt that Mars once had a very different climate. But here's where things get really interesting. For Mars to have had liquid water, it must have had a thicker atmosphere. Today, Mars's atmosphere is barely 1% the density of Earth's, so thin that water would instantly boil away in the low pressure. But billions of years ago, things were different. Scientists believe Mars's atmosphere was rich in carbon dioxide, creating a greenhouse effect that trapped heat, just like on Earth. This kept the planet warm enough for rivers and lakes to exist, but Mars had a problem, one that Earth doesn't. Size matters in the grand scheme of planetary survival, and Mars is small, only half the size of Earth. And with less mass comes weaker gravity. This made it much harder for Mars to hold onto its atmosphere. But weak gravity alone wasn't enough to destroy an entire planet's climate. Something else had to happen. Something catastrophic. To find the answer, we need to look beneath Mars's surface to its core. Earth is alive, not just on the surface, but deep inside. Our planet's core is a churning molten sea of iron and nickel, spinning like a giant dynamo. This motion generates Earth's magnetic field, an invisible shield that protects us from the sun's deadly radiation. Without it, solar winds, powerful streams of charged particles from the sun, would strip away our atmosphere, just like peeling layers off an onion. Mars wasn't so lucky. At some point in its history, Mars's core stopped moving. Maybe it cooled too fast, or maybe a massive impact disrupted its internal structure. Whatever the reason, its magnetic field weakened and then disappeared entirely. And when that happened, Mars lost its only defense against the sun. Without a magnetic shield, solar winds began ripping away Mars's atmosphere, stripping it molecule by molecule. Over millions of years, the once thick air was reduced to almost nothing. With no atmosphere to trap heat, the planet grew colder. Water once flowing freely either froze or escaped into space. The lakes disappeared, the rivers dried up. The planet was left with nothing but dust and memories of what once was. But here's the most unsettling part. This wasn't an instant catastrophe. Mars didn't die overnight. It was a slow, agonizing transformation that took millions of years. There was no single disaster, no sudden event, just a long, quiet death, and yet, even after all that, Mars still holds secrets. Deep beneath the surface, Frozen glaciers hide beneath layers of dust. At the planet's poles, enormous ice caps hold more water than anyone expected. And in the darkest corners of Mars, scientists have detected strange, fleeting signals, possible hints of liquid water still flowing deep underground. Could something still be alive down there? Tiny, resilient microbes clinging to existence in the last remaining pockets of moisture. And if Mars was once a world of water and warmth, could it have once hosted something more? More than just microbes, perhaps even complex life? If so, where did it go? As we move forward, we'll uncover the full story of Mars's transformation. How it lost everything, what clues remain, and what this ancient world can teach us about our own planet's fate. Because if Mars could go from a paradise to a wasteland, who's to say Earth couldn't follow the same path? The great mystery of Mars isn't just that it once had water, it's that it lost everything. But when exactly did this happen? And could there have been a time when life, real biological life, flourished on the red planet before its downfall? To answer that, we have to go back even further, 4.5 billion years ago, to the birth of the solar system. In those early days, things were violent. Planets were still forming, smashing into each other like marbles in a cosmic game of chance. Mars was no exception. It was born from fire and chaos, a molten world that slowly cooled over time. And here's where things get interesting. Mars may have had an ocean before Earth did. Yes, you heard that right. Some scientists believe that while Earth was still a hellish wasteland covered in lava, Mars had already started to settle down. It formed a crust, an atmosphere, and possibly a vast ocean covering much of its northern hemisphere. This is based on topographic maps from orbiters, which show what look like ancient shorelines, coastlines that stretch for thousands of miles. If true, this would mean Mars had a stable, warm climate early on, making it one of the first, potentially, habitable planets in the solar system. But warm oceans and rivers alone don't make a planet truly alive. The real question is, could Mars have developed life? On Earth, life took hold surprisingly fast. As soon as conditions were right, liquid water, a stable climate, the right chemical ingredients, life appeared. Microbes emerged in deep-sea vents, thriving off heat and minerals. So if Mars had all the same conditions, could the same thing have happened there? To find out, scientists have searched for evidence of ancient life, fossilized microbes, organic molecules, chemical traces that point to biological activity. And in recent years, they've found some astonishing clues. The Curiosity rover discovered complex organic molecules buried in Martian rock, molecules that, on Earth, are usually associated with life. Even more intriguingly, seasonal spikes of methane have been detected in the atmosphere. Why is that important? Because on Earth, most methane comes from biological sources, living organisms. Of course, there's another possibility. Mars's methane could come from geological activity, chemical reactions between rocks and water underground. But here's the problem. Mars isn't geologically active anymore. Its volcanoes are dead. Its crust is quiet. So where is this methane coming from? Could it be a sign of microbial life still lurking beneath the surface, hidden away in underground pockets of liquid water? If Mars did host life in its early days, it likely followed a similar path to early Earth, microbes forming in water, evolving, spreading. But then, as the planet's climate changed, life would have faced a crisis. As the atmosphere thinned, the water disappeared. Any surface life would have been wiped out. But could some of it have survived underground? Here's where things take an eerie turn. On Earth, scientists have discovered microbes that live in some of the harshest places imaginable, inside rocks, beneath ice sheets, even miles underground in complete darkness. These extremophiles can survive without sunlight, feeding off chemical reactions instead. If life ever existed on Mars, and if it had time to adapt, could it have followed a similar path, retreating underground, surviving in hidden caves, or deep beneath the surface? It sounds like science fiction, but we may be closer to an answer than you think. In the coming years, NASA's Perseverance rover will send back samples from Mars, allowing scientists to examine Martian soil up close for the first time. If we find fossilized microbes or even traces of past biological activity, it would be the biggest discovery in history. The confirmation that life isn't unique to Earth. But here's a more unsettling thought. If Mars did have life, and it died out, what does that mean for us? Mars had everything: a thick atmosphere, liquid water, a climate that seemed perfect, and yet it all vanished. The question we have to ask ourselves is, could the same fate ever befall Earth? Are the forces that killed Mars still at work today, lurking in the background, waiting for their moment? Because here's the truth. Planets change, climates shift, and sometimes nature doesn't care about what survives. For a moment, let's imagine an alternate history. What if Mars had held on just a little longer? What if its magnetic field had survived, its atmosphere had remained thick, and its oceans had never vanished? Could Mars have been a second Earth, an alien world teeming with life, evolving alongside our own? It's an incredible thought. But reality tells a different story. Mars didn't just lose its water and atmosphere, it lost its future. And to understand why, we need to look at the forces that shaped its downfall. Because what happened to Mars wasn't just bad luck, it was written into the planet's very nature. One of the biggest factors in Mars's fate is something most people wouldn't think about: its size. Mars is about half the diameter of Earth, which means it has far less mass. That might not seem like a big deal, but in the grand scheme of planetary survival, it's everything. A smaller planet cools much faster than a larger one. Think of a cup of coffee versus a huge pot of soup. The smaller one loses heat much quicker. The same thing happened to Mars. Billions of years ago, Mars had a molten core just like Earth does today. That core was spinning, creating a magnetic field that shielded the planet from solar radiation. But as Mars cooled, something catastrophic happened. Its core began to freeze. The churning metal that once generated a protective magnetic shield slowed, then stopped. And when that happened, the sun had free rein to do what it does best: destroy. Without a magnetic field, the solar wind stripped away Mars's atmosphere, molecule by molecule. Imagine a planet being sandblasted for millions of years, its protective layers peeled away bit by bit. That's exactly what happened. With every passing century, Mars lost more of its air, until it was too thin to support liquid water. Rivers dried up, oceans evaporated into space. And then, something even stranger happened. As the atmosphere thinned, temperatures plummeted. Mars, once warm and wet, became a frozen wasteland. But here's the twist: Mars isn't completely dead. Even today it has massive reserves of water, but they're trapped in ice. At the poles, Mars has enormous ice caps, made of both frozen water and solid carbon dioxide, what we call dry ice. But that's not all. Hidden beneath the Martian surface, buried under layers of rock and dust, are vast glaciers, entire frozen lakes and rivers locked away for millions of years. And some scientists believe there may still be liquid water, deep underground, where heat from the planet's interior could keep it from freezing. And where there's water, there's the potential for life. But here's the most unsettling question of all. Could Mars ever wake up? What if, buried beneath the ice, Mars still has the potential to become something more? What if, under the right conditions, the planet could be reborn? Because here's something incredible. Mars still changes. Every so often, Mars undergoes what's known as climate cycles, periods where its tilt shifts, its ice caps shrink, and temperatures rise. Scientists believe that in the past, these cycles may have temporarily melted ice, releasing water onto the surface once again. Could something like this happen again? Could Mars, even for a brief moment, become warm enough to support life once more? And if that's possible, could we be the ones to bring it back? As technology advances, some scientists are seriously considering the idea of terraforming Mars, turning it into a world where humans could live without spacesuits, where plants could grow, and where lakes and rivers could flow again. It sounds like science fiction, but the ideas behind it are real. One theory suggests releasing greenhouse gases like carbon dioxide trapped in Martian ice to thicken the atmosphere and warm the planet. Another idea involves using giant space mirrors to reflect sunlight onto Mars, heating it up just enough to melt the ice. Some even propose nuclear explosions, detonating bombs at the poles to release trapped gases and jumpstart a new atmosphere. But could we really bring a dead planet back to life? The truth is, we don't know. Mars may be too far gone. The loss of its magnetic field means any new atmosphere we create could just be stripped away again by the sun. And without plate tectonics, without the natural recycling of carbon and minerals like on Earth, Mars might never be able to sustain a true self-regulating climate. But that hasn't stopped us from trying. Right now, rovers are searching for answers. Scientists are studying Mars's ice, its air, its ancient rocks, looking for clues about its past and possibilities for its future. And in the coming decades, humans will walk on Mars for the first time, not just as explorers but as pioneers. Because even if we can't bring Mars back to life, we might be able to make it our own. The real question is, should we? If Mars once had life, if it still has something clinging to survival underground, do we have the right to interfere? Would terraforming Mars be a second chance for a lost world, or an invasion of a planet that was never meant to be ours? And if Mars can never be restored, what does it mean for us? Or, because if a planet that once had oceans and an atmosphere could be reduced to dust and ice, what's stopping the same thing from happening here? Because Mars didn't just lose its air, it didn't just lose its water, it lost the fight to survive. And as we look to the stars, dreaming of new homes and new worlds, we have to ask ourselves, can we learn from Mars's mistakes before it's too late? Mars is more than just a dead world, it's a warning, a time capsule frozen in the past, showing us what happens when a planet loses its balance. And yet, we keep looking at Mars, not just as a relic, but as a promise. In the next few decades, humans will set foot on Mars. This isn't science fiction anymore. NASA, SpaceX, and other space agencies around the world are actively working toward this goal. The Artemis program, set to return humans to the Moon, is only the first step. The ultimate mission? To take what we learn on the Moon and use it to go farther, to Mars. But why? Why spend billions of dollars, risk human lives, and dedicate decades of research just to set foot on a barren, frozen wasteland? Because Mars is the only other planet in the solar system where humans could one day live. Venus is a furnace. Jupiter, Saturn, Uranus, and Neptune are gas giants with no solid ground. The icy moons of the outer planets, Europa, Enceladus, Titan, are fascinating, but they're impossibly far away. Mars is the only world that, with enough effort, we might be able to transform into a second home. But here's the hard truth. Living on Mars won't be easy. Mars isn't just cold, it's deadly. The atmosphere is less than 1% the thickness of Earth's. There's no breathable oxygen, no liquid water on the surface, and radiation from the sun constantly bombards the planet, unfiltered by any protective magnetic field. Just standing outside without a spacesuit would kill you in seconds. So how do we survive? Future Martian pioneers will likely live in underground shelters or in domed cities, shielded from radiation. They'll extract water from ice deposits and generate oxygen from chemical reactions. They'll grow food in controlled environments, using artificial lighting and hydroponic systems. Everything will be carefully planned, every resource carefully managed. But even if we survive, will we ever thrive? That's the real challenge. Because Mars won't change for us. We have to change for it. Life on Mars would mean adapting to a reality where every breath is a calculated effort, where every mistake is fatal, where stepping outside without a pressurized suit isn't just uncomfortable, it's a death sentence. Over generations, would humans begin to evolve? Would we become something different, stronger, more resilient, shaped by a world that doesn't care if we live or die? And what happens if Mars is not as dead as we think? Because right now, we assume Mars is lifeless. We assume it's empty. But what if we're wrong? What if buried deep beneath the surface, microbial life still exists, clinging to survival in ways we can't yet detect? What if Mars already has life, and we're about to disrupt it? It's one of the biggest ethical dilemmas of our time. If we terraform Mars, if we release greenhouse gases, introduce Earth-based organisms and change the planet's climate, we might be committing planetary genocide, wiping out an ancient alien ecosystem before we even realize it's there. And Even if Mars is empty now, who's to say it would stay that way? If we introduce bacteria, fungi and plants, would they evolve differently in Martian conditions? Could we accidentally create new life, organisms that don't exist anywhere else in the universe? This isn't just about survival, it's about responsibility. Because for the first time in human history, we are standing on the edge of a decision that no species has ever faced before: the power to reshape an entire world. We are no longer just explorers, we are creators, and with that power comes a question we cannot ignore, should we? Because Mars didn't die all at once. It wasn't destroyed by an asteroid or burned by its sun. It faded slowly over millions of years. A planet that once had lakes, rivers, maybe even oceans, lost its ability to sustain life. And in doing so, it left behind a lesson, a warning, because if Mars, a world so similar to our own, could fall, what's stopping the same thing from happening here? Right now, Earth is changing. The planet is heating up. Ice caps are melting. Weather patterns are shifting. Species are disappearing. And though we like to think of Earth as indestructible, history tells us otherwise. The question isn't just whether we can save Mars. The question is, can we save ourselves? Because as we dream of new worlds, we cannot forget the one we already have. Mars shows us what happens when a planet loses its ability to sustain life. And if we don't learn from its past, we might just be seeing our own future. And that's where we leave it to you. What do you think? Should we terraform Mars? Should humans settle there, even if it means changing the planet forever? Or should Mars remain untouched, a relic of what once was? Let us know your thoughts in the comments below. And if you enjoyed this journey through the rise and fall of the red planet, give this video a like and share it with fellow space enthusiasts. The universe is full of mysteries, and we'll be right here to explore them with you. Until next time, keep wondering and keep looking up.